Hi everyone, and welcome to our last Edinburgh Reproducibility session of 2023. We've got an external speaker with us here today. We've got Kaveh, who is here to talk to us about questionable conduct in images and figures in scholarly publishing, which is obviously quite an important topic at the moment. So Kaveh is a physicist with a PhD in display holography, and he's founded River Valley Technologies to introduce computer-generated illustrations to UK publishers. So I'll let you take it away, Kaveh. Thank you for joining us.
Thank you, and thank you for the invitation. I've been to several of your presentations, so it's a great honor to actually be speaking. I hope it's of interest. So very briefly, just as you don't know me, we've been in scholarly publishing for 35 years now. I used to be very proud, but now I'm just old. We are based in UK and in India, in Kerala, one of the best states in India. So we're very happy that we're down there. We've got our staff, on average, they've been with us 17 years, so they're more like a family. And I really couldn't resist putting a little video for a couple of slides in the corner. So during the pandemic, they were locked up for 3 years, and this is in August last year, this is the Harvest Festival, and they had a really good time, and they made a beautiful video, which you can see. I'll put a link to it in case you want to see it. These are all our staff, actually. Amazingly, they're good dancers too. So we started as typesetters, technical typesetters in the old days. And then we move now into more platforms for publishing. So we produce we create the platforms for anything from submission and peer review to the typesetting to the final publication. We believe in open standards, open science, open fair data, etc. Our clients are large and small scholarly clients, and also societies. We've worked with lots of people. Now, I've got lots of slides, and what I've done, I've got a QR code here that you can go to whichever it goes to the relevant place, but also I'm going to put in the chat, if I may, a link to this is a PDF, okay, of my talk. So there's something like 100 slides. I'm zooming through them, but you will see that all of these, the QR code is actually a link. So in the PDF that you download, you can click on that later. So you don't have to take notes. If you click on that, that'll go to the relevant place. Okay, so these are all clickable. So I've tried to make that easier. I hope that works. So everything you see here, you can just click later. If it doesn't work, let me know, but I tested it. So that's a client we've got, an example client we've got is Gigabyte. They are fully open in everything, and they're pushing the boundaries of publishing. I won't say anything more about about us, but you can go to that link and have a look. So my interest in graphics actually started early on. I see that I've always been interested in graphics. I did the world's first PhD in display holography or pictorial holography, the most realistic 3D images. This is made by Rob Monday, a friend and a colleague who's one of the best holographers in the world, who made the hologram with Her Majesty the Queen as well, the late Queen. So, and then graphics, I looked back at what I was doing in the very, very early days before most of you were born. I got interested in graphics, and this, you can see the date on here, 1978. That's when I started roughly in computer graphics. And the only way you could do it was you wrote a program, you sent it to something called microfilm, which is like 35mm negative film, but without the sprockets. This came back from the University of London Computer Center in a van. So I wrote all the programs in Fortran, I believe, to create my graphics. And when I got this negative, if you like, I put it in the enlarger. I see a little bit of hissing coming from the computer, so I'm just going to put my headphones, perhaps improve the sound. So basically, when this came back, I took it into the photography into the lab, in the room, printed it on an enlarger, and this was my computer-generated image. It was just, very, very early days. And the text would typeset the text, and instantly I found that I am actually using the first user of LaTeX, tech in those days in Imperial College. And so this is partly why the thesis took 3 years to write, because I had to get it absolutely right. So this is tech in the very early days with computer graphics. And how do you stick them together? Well, there was a thing called cow gum in those days. So this is the early days, folks. When I heard about Adobe Illustrator, I pre-ordered it, and this is version 1 of Adobe Illustrator, complete with the VHS video tutorial that you put in your VHS recorder player. And I ended up again, sorry, it's all about me so far. This is the very first book in the UK, published in 1991 with computer-generated illustrations, and I did all of those in using Adobe Illustrator. So we talk about image misconduct, if you like. Is there any software to pick up if someone's copied or manipulated image? Well, there is some software. There's the one I've used is Image Twin. What it does, you upload a PDF file or you paste an image, and it tells you at the top, it says duplication within the image, and then duplications with other publications that they have a database for. It's useful, but so it's a combination. People find this using a combination of such software and just using their eye. I'm just the messenger, folks. So the people who are finding these, there are many, but this is not. It's just the 4 that me and my colleagues have done animations for. Elizabeth Bick, world famous now, Cheshire, Smut, and Sholto. These are people just came to my mind, but there are many others. By the way, in the PDF, if you want to find out more, you can. All of these are clickable, so you can just find out more if you want to. These people are generally, they're unpaid. They're interested in making sure that research is correct. People are not cheating, if you like. And really, I have a lot of respect for them, especially for Elizabeth, who's taken a lot of flack. And by the way, what I'm going to show you, we are just doing this, myself and my colleagues. Whenever we have free time, we'll contribute something. There's no business model here. This is just done in our free time. We should really, this is not a nice image, folks, but Elizabeth Bick gets a lot of attack. This is from about 2 weeks ago. Someone put a news online, said, Bick, you will pay. This poor Elizabeth goes through a lot of this, but she keeps going because she believes in what she's doing. So respect to these guys. If you have any interest in this, PubPeer is the place you should go to. PubPeer is a site where anyone can go and make comments, positive or negative, about any publication. Okay, it's quite nicely set up. So you can go in there and search. So for example, when you go in there, PubPeer gives you a pseudonym, which is some sort of organism or something. So my pseudonym that's being given, or me and my colleagues, it's Ilex something. I can't even remember the second part. But basically, anything from us is Ilex. So if you search for Ilex, you'll see there's 1,300 contributions from us. And it's got quite a good search. So if you say Ilex, Elizabeth Bick, these are 266 that we have commented, and Elizabeth is on the same thread as well. And there's some basic sort of clever searching. So fig star, that it contains fig, figure, or figures, etc. I highly recommend the PubPeer extension, folks. So this is a really nice extension to a browser. And the way it works is if you're on any page, if there's a DOI, that has an entry in PubPeer, it pops up with a link to PubPeer. So it's transparent in the background, it doesn't get in your way, but you can click on it anytime. If there's something questionable, or if there's any comment at all, you can go there. So I highly recommend you install that extension. The publishers are looking into this, so the publishers know there's a potential problem here, or there is a problem. There's the STM Association, STM Integrity Hub. They're looking into things, and I won't go into details, but there's a link to the page. A couple of days ago, actually, it was the STM Research Integrity Day, which I went to, and these are just some of the sleuths, if you like, who work in this area. You've got Anna Abalkina, who's doing some clever stuff to find fraudulent publications. I don't even know what she's doing. Very clever. Cyril Labé, I'll come to later. And then Boris Barber actually set up, one of the founders of PubPeer. Just briefly, there are lots of things going on in publishing. People are trying to publish tortured phrases. It's sad and funny at the same time. Basically, publishers have software, normally called Authenticate, which looks for plagiarism. So if you were to take a paragraph somewhere and try and publish it, there's a database. It'll go back and find that and say, no, this is plagiarized. People try to get around it. So there's another software they put their paper in, which changes the words a little bit, and the idea is that it'll get around the plagiarism software. Unfortunately, it puts strange words in. For example, breast cancer changes to bosom peril, and so that gets around the plagiarism software. I'm just mentioning it because these are other problems. Fuzzy logic becomes fluffy rationale. Hilarious, but really sad at the same time. And if you think this is a small problem, folks, and by the way, the Cyril Labé you saw in the last photo and Guillaume Cabanac set up something called the problematic paper screener. It's like 4,000 sets of phrases that keep getting repeated. If you go into Google Scholar, search for fluffy rationale, there are over 900 publications already up there with fluffy rationale. So there are problems in here, but I'm not going to get into those today. But today I'd like to talk about what image misconduct, if you like. We can start with simple duplication. So for example, here we have these are supposed to be two different pictures, but someone's looked at it, people like Elizabeth Bick, Dr. Elizabeth Bick, and they found that actually these two are the same. So if you like, our contribution here is we make this animation to show what other people have found. So this is another one where these are supposed to be, by the way, I'm not a biologist at all. I don't know what these are, but they're supposed to be different samples. And yeah, these are pretty good. Now you can see the resolution is not perfect, so it's not quite matching, but it's probably the same image. People can rotate the images so that they're more difficult to find. So again, this is supposed to be, I'm guessing, two different samples, and slight rotation. Yeah, so this is actually the same image that's been cut up. And they're pretending it's different. Here's one more example. Yeah, same image with a little bit of changing. Scaling, so that's pretty common. So these two, I guess it's supposed to be a different thing, but actually when you overlay them and you scale them, you find that they're exactly the same picture. They've been scaled and they shouldn't be. Here's one more. It's very difficult to find these, it's only these people with really good eyes can see them. But if you take this now and scale, you find that, yeah, these are actually the same thing. I'm just zooming through this to show the different sort of types of things that we've seen. So now if you put the positive you find that, yeah, it's exactly the same thing. Now, that's duplication. A little bit more sort of suspicious and more difficult to explain is when there's manipulation as well. So here we can see the right-hand side is, yeah, that more or less matches, but the left-hand side, someone's put a few more dots in for whatever reason. So that's a bit more difficult to explain. They can't say, well, sorry, I put the wrong picture in. This is another one where almost impossible. Someone looked at these patterns and thought they're similar. Now, it's very difficult just looking side by side to see that there's any sort of misconduct going on, but you can see here that it's not just duplication. Someone's put a few more dots into for whatever reason. So, yeah, you can see that they're almost the same, but not quite. And just one more example here. Yeah, almost matches, but a little bit of photoshopping going on. So here again by eye, it's not clear that these are the same, but you rotate, overlay, definitely something not quite right here with those blotches. I see a lot of what, again, not my area, but so-called colony plates. I guess they're easy to fake, but you find that these are supposed to be different. When you overlay them, you find that they're almost the same, but not quite. So this is, we really shouldn't have this. This is supposed to be scientific research, and people are doing things they shouldn't be. Scanning electron microscope images, people are quite creative in here. They thought they're not. So they make it a bit more. Well, we'll see if we overlay, and we take one of this pattern here, we find that it's actually been copied. You can see there it's been copied about 4 times here. As I say, some of these they're quite satisfying to do at the same time. You think, well, why are we having this problem? This is another one where the authors thought they'd make this a little more attractive, I guess, overlay, and you find that a lot of these patterns are actually very similar. There we go. And it goes on and on. It's quite a sort of graceful dance that is doing from one to the other. Anyway, there's lots more there. Now this one, again, this becomes even more, it's not very subtle, this one. Once you overlay, you find that, ooh, top left, that's actually been completely painted in. So it's another. A lot of Western blots. These are quite difficult sometimes because they're small, they're low resolution. So these two, again, someone thought, ooh, these are a bit too similar. We overlay them, we find that overall, a lot of that matches, but not quite. And if you look at the, yeah, so definitely a lot of it is the same picture, but if you look at the bottom left, bottom right, you can see that it actually matches if you move it a little bit up and down. So this has been modified in some way. Quite often you get things that are, I think this is reflected. Yeah, so if we reflect this, make it negative and overlay, we find it's the same. Now here, you can see the resolution is not quite high, we're not quite clear, but it looks like it's the same thing. The chances are it's the same one. Yeah, so similar one here. Again, these dot patterns I can't. It looks like it's been copied from a screen print on paper, but who knows? Again, this becomes a little bit questionable. I'll come back. Very important. I'll come back to resolution later. Figure labels. Quite often we find this sort of thing. Now here we have someone noticed that the carpet has been copied. So again, if we overlay this and move it, you can see here in the middle, that's gone. That's obviously been copied from somewhere. Now, I call this labels because certainly what's happened is there was a label here, ABC, and someone wanted to hide it, okay? So this is not a big problem, I guess, because it's just a carpet. It doesn't matter. It's not data. But at times you find that the corners of pictures have been modified. And that's not a good practice. So if you look at the top one, you can see right in the corner, there's a blotch there. Something's happened in that corner. And there are many examples like this. So for example, here, if we again overlay, there's something going on in the top right. Overlay this and then just move it. You can see, there we go. There's a rectangle there. That's almost definitely, there was a label there, but really it's not good practice to take a piece of the picture and Photoshop it. There must be a better solution to that. This is a similar one, some archaeological picture, overlay. Bottom right, you can see suddenly everything matches apart from the bottom right. And I'm guessing there was a big label there and they just Photoshopped it to make it better. And finally, this one, don't quite know what happened here, but if you overlay this again, you find that around this label, there's a sort of fuzzy bit that's been copied from elsewhere as well. So that's probably got to do with that label. Probably not they weren't trying to, cheat or anything, but not a good idea. A lot of photos of objects in the lab, you can see A and B, they look the same, but one's got bubbles on the left-hand side. Actually, if you enlarge one and overlay, you find actually these are exactly the same photo, even the scratches match, but someone's put 3 bubbles in. That is a bit naughty, I would have thought. This is another one where these are supposed to be different samples, slightly different aspect ratio of these two. However, if you modify and slightly change the aspect ratio, you find they're exactly the same picture. There we go, bingo. A lot of animals in the lab. I feel a bit bad about this actually. Again, rats and mice, for example. These are, I think these are called exit wounds. So here you can see these are slightly different. Control day 3, control day 7. Well, hey presto, if you just enlarge one, you find that even the ruler's been stretched. And the reason I feel bad about this, I feel that if you're using animals in experiment, and even if you've got the permission to ethical permission or what have you, it is not a good thing to torture animals, if you like, and then cheat because they've died for nothing. Yeah, this is another one. There are lots of these, by the way. So these are supposed to be different experiments, but if you overlay them, you find that actually there are only 2 of these match, and someone's just put a different picture on it. So not very good. All of these are hundreds and hundreds of them. Before and after, there's quite a few of these. On the left, these are supposed to be 3 different samples. But if you take this one and scale it a little bit, you find it's actually exactly the same picture, but it's been moved. Here, I guess some sort of clever facelift to make someone look younger. And if you overlay, you find that actually the hair is the same, the lips are the same, but the smile is different. So this is definitely not a before and after. And there was a dentist near me. I saw this picture. I thought, this looks dodgy. I looked it up online, found a good quality picture. And as expected, these are exactly the same picture. Teeth have been photoshopped. If only it was so easy to fix the teeth. Often we find background noise the image itself is not so sharp, but the background noise is sharp, and you can find duplications by matching the background noise. I don't know how this was found, but if you overlay this, they cancel out, move it a little bit, you find that, yeah, this is obviously being copied from somewhere. And then quite often you find these Western blots where you overlay cancels that. But then if you move it a little bit, you find that this shouldn't be, this noise shouldn't be cancelling out. So that's been pasted somewhere. I'll just move along because we've seen that. This is another one where this is quite a high profile case, I believe, where someone noticed that the noise was exactly the same in several of these. So these blots have been pasted in or copied. And this is one more of example of noise. We increase the contrast and we just take the top part. So yeah, this cancels out. If you move it, you find that suddenly you've got another bar. So something dodgy going on here as well. They copied something. I just came up with this name, cascading images. Often you find, here we have, what, A, B, C, D to H. These are, I'm guessing these are supposed to be different samples. Someone said, this doesn't look right. And so if you take some of these negative, make them negative, overlay them, you find that 7 of them are from exactly the same sample. So something not right there. Again, it's fun to do, but obviously not very good, because someone's taking this paper, maybe purchased it, some early career researcher is trying to work out what's going on, and it's a complete cheat. And this, I won't show all of it, but it turns out all of these pictures are actually from two sets. And they've just been, I'll just show you a little of it. And they basically, it's 2 pictures and they all overlap like this. Yeah. I just fast forward it, you find that's another one, and they all match together. And by the end, you find that there are the 2 sets of these, and yeah. So that's another example. Very, very often you find 2 images where there's a tiny, tiny bit that overlap. And again, I don't know how people found this, but if you zoom into this, you can see that this is actually, this whole thing was from the same picture. The reason I'm showing this is really to underline that if this hadn't overlapped, maybe we would never find out. So maybe this is the tip of the iceberg, that there are lots of images and we happen to see these because someone was not careful enough and they overlap. Here's another one. There are many, many of these, what I call edge overlaps. Yeah, I don't know. X-ray, X-audio, X-ray diffraction spectra. There are hundreds, maybe thousands of these. I don't know how they just go through and they get published, and many of them are exactly the same. So these 2 spectra are actually completely identical. Quite often you get vertical scaling. So if you look at the bottom 3, they're actually the same thing, but they've just been scaled. That's all. I'll just show you a little of that. So take the bottom one. Scale, and that matches. Yeah, it's actually that's a perfect match. And I'll come to the ones which are not perfect match. Scale a little bit more. There we go. Okay. There's a huge amount of what I call horizontal noise replication. So this is supposed to be noise, but if you actually take a part of it, you find that the noise is replicating. There's really a nauseating number of these that are clearly being just photoshopped. So that's one. And if you take this, these look different, and they all look different. However, if you overlap, you find that if you zoom into I think the right-hand side, you find that the tail end is actually being copied from one to the other because someone thought this doesn't look quite wide enough. And then lots and lots of XRD, X-ray diffraction patterns with manipulation. So these look, actually, if you look at these, they look pretty similar, but they've been copied and then manipulated. So I'll just show you the first bit of this. So that matches, but you can see on the left, not quite. However, if you move it up a little bit, or left or right, you find that it does match. So there we go. Yeah. So many of these I get bored, so right, resolution. This, as you can see, is a very low resolution image. Overlap. Just about see the same image, but you know, the resolution is so low that you can't quite tell. This is another one where someone said these look like the same image, but you're getting to a point where it becomes debatable, and there's a lot of debate. If you go on PubPeer, the author comes back and says, no, look at the spec on the top right-hand side. Someone says, you know, we're having these arguments about whether these are the same or not. I'd say these are probably the same. This is another one I'll jump through. No need to go see all of these. And this, I don't know how this got published. The y-axis isn't even straight. This is from about 20, 25 years ago, but still, we should have better quality publications than this. Not only is it low resolution, it absolutely matches as well. So a bit depressing. On the other hand, you get a lot of high resolution images. So if we look at this one, let's overlap it. And then someone said there's something dodgy about this. When you move it, you can see, actually, because it's high resolution, you actually see the marks, the brush marks in whatever software they used. Yeah. So with high resolution images, there's less debate about whether you know these are the same or not. This is another high resolution image. Overlap it, you can see it's pretty good match, but you can see some of this dots in the middle. You see that is not the same. That's been modified, but the rest of it is exactly the same. And so when you overlay it, you can see it's the same image, but when you overload the other one, you can see this dot moves a little bit. People are using some Photoshop tools. There's a clone stamp tool where you click or control click on a part, and then you can just paint it somewhere else. Okay, that's quite popular. You can see people have done that. A bit more, the next version up is content aware fill, where you select select an object and say, please get rid of this, and it gets rid of it in a kind of clever way. And this, I'm thankful for Jana Christopher, someone who's very active in this area. With the content aware tool, she selected this and say, get rid of it. And you can see on the right, it's fixed it. Very difficult to tell this, but when you overlay, you find that it does, you can see a sort of rectangle. That's how it's done it. And so this one, that's where I think what happened here, someone said, look, improve this for me, and Photoshop improved it. If you look here and just move it a little bit, you can see that the two rectangles, more or less, that shouldn't be there. The most frightening thing is generative AI, which everyone's talking about. Now, Photoshop have a new thing called generative AI, where you take this picture here and you say, you can just type in, put a classic car from the 1950s. It puts a classic car from the 1950s, importantly, with the shadows in the right place and blending into the image. Yeah. Then you say put a reflection pool filled with blue. It does it, and it has a reflection of the car. And you say put in a cloud, it puts in a cloud. Make it landscape, but it makes it landscape for you. So I have no idea how we're going to find images that have been manipulated in this way. This is quite frightening. I came across, I want to give credit to everyone I found, but Professor Orbinsky, he used generative AI, and he took the image on the left and said, oh, can you get rid of this cell or whatever it is for me? And it got rid of it. And if we overlap it, you can see that, but Photoshop's done a good job here, and it's very difficult to tell. From if you don't have the image on the left, well, it's difficult to say that this is not a real image. So So finally, guys, what is the answer? What do we do? How can we stop graphics problems in graphics? Something hit me a few months ago. It's so obvious. It's the elephant in the room. Let's look at file sizes. A selfie that we all take and teenagers take and send to each other and kids send all the time is something of the order of 2 megabytes, okay? A 1 minute video is 10 or 20 megabytes. 1 minute animation is 40 megabytes, very, very roughly. My presentation to you today, because it's full of these videos, is 2.8 gigabytes, yeah? An article PDF that you download is of the order of 2 megabytes. So why are we not? Why are the PDFs not 50 megabytes, 100 megabytes, but with a low resolution version? I feel that if that is the case, then we can have a better, we can test we have a better way of going forward. Lossy compression, JPEG, what it does is randomizes patterns. So on the left, you have a 600K image. On the right, you have a 45K image. If you zoom in, you'll see on the right these typical the squares that come up. It's actually randomizing the pixels to make it smaller. This is not good for science, I feel, and if possible, we should avoid this. This image is probably something like 20K. So what I'm saying is we seem to be, you know, if I send a selfie with a low resolution image, people will complain. But why are we publishing scientific papers with low resolution images? Vector files, of course, as you probably know, vector files don't have pixels. They basically, you can zoom in as much as you like, and it'll always be sharp. So my final slide is my recommendation. Use vector files where possible. Demand from scientists and from authors, demand and publish high resolution images. Minimize JPEG compression. This is not a good thing to do, to randomize pixels in science. Go from 2 megabytes to say 50 megabytes, but have a downsampled version available if people really have a problem with file size. At the very least, demand highest possible resolution to be uploaded in supplementary data. So if you've got a small file, at the very least, dump whatever you've got at the highest resolution possible so that people like me who come along and say, are these the same? You can find that. And by the way, you don't need to prepare labels, etc. They can be just dump them somewhere for future. And that's me. Thank you.
Thanks, Kaveh. That was an amazing presentation. Very, very scary as well.
Yeah.
With how all the different ways that images can be manipulated and quite how common it is as well. I'll switch off the recording just now, and we've already got some questions in the chat, but everyone else, if you want to put your questions in the chat or stick your hand up and ask questions, we'll go through the chat questions first.